MBA633 instructional video created by Professor Amit Tata, School of Management, George Mason University. We'll continue now with our clips on measures of location. We've already seen how to compute measures of the middle of a data set, namely the mean and the median. We move on to other measures of location commonly used, in particular quartiles and percentiles. For example, if you are a Mercedes dealer or thinking of opening a French restaurant, perhaps you might be interested in knowing the top 25% of the salaries that you see over here. What is the top 25%, or what is the top 10% instead of the middle? So there are various reasons why one might want to know locations in the data other than the middle. And two common types of locations that are non-center oriented are quartiles and percentiles. Now the idea behind both are fairly similar. In the case of quartiles, basically what you conceptually think of is take the data set and divide it off into 4 buckets, each holding about 25% of the values, and then you compute where the boundaries, each of those boundaries lie. Similarly, in the case of percentiles, you take the data set and divide it off into 100 buckets, each holding about 1% of the values. Clearly, using percentiles makes sense if you have a lot of values. If you have only 50 values or 50 observations in your data set, it really doesn't make a whole lot of sense to be using percentiles. But in this case, we have a small example. We have 111 students, so we will still compute those, but remember that using percentiles really is meaningful only when you have fairly large data sets and you have a reasonable number of values in each bucket, and you're not fighting for one value to go into one bucket or the other. Okay, so let's start with quartiles. Let's say we have these 111 students, and we know their monthly salaries here, with column C being the sorted salaries as before, and we want to compute the first quartile. Okay, so you've divided off the data 111 off into 4 buckets, and the first quartile, we want to know where what that value is. Okay, so the first thing we want to do is get the index, just like we did for the median. So if you think of 111 values and we divided it off into into 4 buckets, where does the first bucket end and the second bucket begin? Where is that location? So we have 111 values, so clearly the index would be 111 divided by 4, so that's 27.75, and since we don't have the 27.75th value, that doesn't exist, we rounded it off to 28, meaning what this index means. Notice that this index 28 depended only on the number of values, not on the salaries. Okay, the number of data points, not on the actual data values. So what 28 means is that after we have sorted the salaries in ascending order, the first quartile, the boundary of where the first bucket ends and the second bucket begins, is to be found at the 28th value, or the 28th student. So let's scroll down and see what that value is. So here is the 28th student, so the value is $3,155. So let me write that down, is $3,155. Just like with the median, we don't have to do this eyeballing and sorting manually. There is a built-in function in Excel to do quartiles, and which is the word quartile itself. So let's apply that. Quartile. And I will highlight the values, and notice I can highlight the unsorted values. I don't need to sort them prior to applying the built-in function. I did the sorting simply to show you the mechanics of how the computation is done. So I highlight the entire data set, and I say that I want the first quartile. Okay, and the value that I get, notice, is slightly different, is 3165. Okay, and you will see this when you use Excel. In other words, when you use the built-in function in Excel, the value that you get may be slightly different from the value that we got through a manual calculation. And the reason is simple, is that when we did the manual calculation and came up with the conclusion that the first quartile is the 28th value, that was simply an approximation. So strictly speaking, it should be the 27.75th value. And what Excel tries to do when it comes up with these things is it tries to do some interpolation in a way that it thinks is better than simple rounding up. So you will get values that are slightly different. So remember, the manual calculation that we did is simply to make life simpler for us and not have to go through complicated interpolation calculations. And when you do use the built-in function, you might get slightly different answers. For practical data sets, I would urge you to just use the Excel built-in function and pick up whatever value is produced by the built-in function. So again, the reason we are doing the manual calculation is just to show you the concept behind the calculation. Then you let the software do the actual computation for you. Okay, so let's try the percentile now. So here we want to compute the 75th percentile. Okay, so just as with the quartile calculation, the first step is to find the index. In other words, where is the 75th value 75th percentile located? What is the index in the data? What is the position in the data set? So since we have again 111 values, the 75th position is 111 divided by 100 times 75. So remember, look at this calculation. We took the entire data set, split it off into 100 buckets. That is why we divided it by 100, and then we want the 75th bucket. Okay, so that's why it's times 75. So then we come up with 83.25. In other words, again, if we use the crude principle of rounding up, because it's a fractional number, we cannot locate the 83.25th value conveniently. So we just rounded it up to 84. So by a very crude approximation manually, what we are saying is the 75th percentile is simply the 84th value in the data set. So obviously after it's been sorted. So let's scroll down and see what the 84th value is. Oh, again, too far down. Here is the 84th value. It turned out to be $4,040. So let's use 4,000. So this is what we got manually. Again, Excel has a built-in function to do percentiles. So let's apply that. So equal to percentile. I highlight the full array, full 111 values, comma, and in Excel, the percentile, you don't specify it as 75, 85, 90, and so forth. You have to specify it as a decimal. So I'll say 0.75. So let me scroll up and so that you can see what I typed in. Notice what I typed in. I said percentile followed by the range of values based on which I'm doing the computation, and then I typed 0.75 as the 75th percentile. Okay, and you can see it came out to 4,025. Again, something slightly different from what we got manually, but don't let that bother you. The manual calculation was again to show you the logic behind how the computation is done. For all practical data sets, you will use the built-in function in Excel and let that do the computation for you. Just like with the median, percentiles and quartiles are less sensitive to extreme values within the buckets or at the ends. So, and you should be able to deduce that based on how these computations were done. The way the quartile and percentiles are computed is very similar to how the median was computed. In fact, now that you've seen the calculation, it should be fairly obvious to you that the median is the same as the 50th percentile and is the same as the second quartile. You can apply the built-in functions percentile, quartile, and see that in fact that is the case. So collectively, the measures of location that we've seen are mean, median, quartiles, and percentiles, and collectively they tell you where the commonly uh, desired positions in the data are located: middles and ends, higher ends, lower ends, and so forth. And the idea again is to be able to convey patterns in the data, um, instead of having to provide the individual data elements themselves.